Alright, so picking up where we left off, yesterday we were just determining how many triangles there were. Right? We did those? Looks like half of it disappeared. We got through number 10, right?
Yeah.
Okay, well it apparently disappeared off my thing. Whatever. Deleted all of my calculus ones from yesterday too. Love that. Anyways, okay. Number 14. So these ones actually give you the triangle, and now we're actually solving for all of the pieces. Obviously, if they give you a triangle drawn, there can't be no triangle or two triangles because they've already given it to you. So it's not a right triangle, but anyways, it kind of looks like it. And so they give us, this is BCA. This is 81 degrees, 33 degrees, and this is 26. So, which scenario do I have here? Yep. This is angle, side. So, I need to solve for the other pieces. So, what can I solve for first? Huh?
B.
Angle B. So, that's going to be 180 minus 81 minus 33. Which is what? $66. So now I need to find the other two sides. Which one do you want to do first? It doesn't matter. A or B? A. Alright. So A over the sine of 33, and I'm just going to reiterate, make sure you're in degree mode, equals 26 over the sine of 81. So A is equal to 26 sine of 33 over the sine of 81. So what is that side length? Huh?
F14, 3.3.
Okay, so 14. So then side B, and again I would use the C stuff because that's what it's what we were given to begin with. So B over the sine of 66 is equal to 26 over the sine of 81. So B equals 26 sine of 66 over the sine of 81. $24? Okay. Okay. Alright, I'm going to jump to the ones where they don't draw the triangle for you, just because the ones where they give you the triangle are pretty easy. But there's obviously more to look for with the ones where they don't give it to you. So, 18. Angle A is 73 degrees. Side A is 18. Side B is 11. So what scenario am I dealing with? So I've got side angle. And then from there, which thing or what do I look at next? Is it acute or obtuse? So what is this one? Acute. So now, looking at my chart, right? So I've got up here, and we fortunately in this problem are using the same letters as our sample up here. So I'm looking first, is A greater than or equal to B? Before I find H. Is A greater than or equal to B? Okay, so A is greater than or equal to B. That means we have one triangle. So I'm going to go through and solve for the other pieces. So what piece do I need to solve for first? What's the only thing I can solve for at the moment? Has to be something I already have part of. Angle B. So it's going to be sine of B over 11 is equal to the sine of 73 over 18. So sine of B is equal to 11 sine of 73 over 18. And if you want to like write it all as one step, like taking the inverse and stuff, that's what I normally do. But for this one, I'll write it out separately. So B equals the inverse sine of 11 sine of 73 over 18.
I got
51. Is that what everyone got?
That's what I did wrong.
I don't think that's right. That's why I'm asking. Unless there's a typo in the book, which is possible.
I got 36.
Yeah, I got 36 too.
Okay. Emma, did you make sure you put the whole thing in?
You might have like missed parentheses. I don't know.
How'd you type it in? Like that?
Mine doesn't look like that.
How did you do it?
I just did.
Or did you do each thing individually?
I just did inverse sine and 11 sine
Did you close the parentheses after the 73?
No.
That's why. Huh?
You just put C
Yeah.
Okay.
Because if you don't, it's taking 73 divided by 18, and that would be why probably that it did that.
Okay.
Yeah.
All right, so now what?
C.
Find C. So angle C is 180 minus 73 minus 36. Huh?
No, 71, not one.
Oh, I was like,
I'm smart. Yeah.
calculator dead again.
Yes, it always does.
If you don't like need it during the day, you can like leave it in here and let
I
it
might
charge like
just
all
do
the
that.
way. Or come back and get it later if you need it for like science or something. I don't know if you need it in that class, but all right, so now I combine side C, so C over the sine of 71 is equal to 18 over the sine of 73. So C equals 18 sine of 71 over the sine of 73. You got 18. Now, obviously, it's kind of like, well, the angle that's 73 degrees is 18 and the angle at 71 is 18. But that kind of makes sense because more than likely these numbers have been rounded, right? Because we rounded a little bit. And so it's totally fine. Some people are like, but they shouldn't be the same thing. Well, they're not technically exactly equal, but with rounding, they end up being. Let's see. 22. Angle A is 55 degrees, angle B is 64 degrees, and side C is 34. Huh? This one's not, but I'll have to draw a picture for you to see why it's not. So I have this angle is 55, this angle is 64, this would be side C over here, which would be 34. So this would actually be angle, side, angle. But as long as you know, because what would we say, angle, side, and angle, side, angle all produce how many triangles? One. So as long as you know that it's only producing one, it doesn't really matter that much, but just visually so you see it. So let's see, 55, 64. So angle C is the easiest thing to find next. So 180 minus 55 minus 64. $61. So now, excuse me, they can find side A and side B. So I'll just do B first. B over the sine of 64 equals 34 over the sine of 61. So B is 34 sine of 64 over the sine of 61.
$35.
35. All right, and then A over the sine of 55 equals 34 over the sine of 61. So A is 34 sine of 55 over the sine of 61.
$32.
32.
So, could you ever, like, say you finished, you solved A and B, and then instead of doing A, or C, you just use Pythagorean theorem?
Is this a right triangle?
Never.
People often try to do that. That's why I say, is it a right triangle? Because you can only use Pythagorean if it's right. All right. 24. Angle C is 98 degrees. Side C is 29. Side A is 33. So, what scenario do I have here? Side angle. Yep, it is obtuse. So, looking at C compared to A. Okay, so in this scenario, looking back at our chart, C is A and B is A. Or A is B. C is A and A is B. Okay, so C is going to be on the left, A is going to be on the right. So, is C greater than or equal to B, or is C, or, sorry, letters. Is C greater than or equal to, or, oh my gosh, okay. Words, I got it. Is C less than or equal to A, or is C greater than A? C is greater than A. Was it? I don't even know. Did I write the right numbers? Yeah, I did. C is less than in this case.
Oh.
I thought I wrote the numbers backwards. I was like, oh no. So C is less than, so that means what?
No triangle?
No triangle. So I would be done at that point. So just make sure you specify that it's no triangle. Don't just like leave it and assume. And I wouldn't have needed to set this up, but I wasn't thinking about it when I did it. I'm just in the habit. Okay. One more like this, and then we'll move into some area problems, which I forgot to give you the area formulas yesterday in your notes for finding area. Anyway, so I'll give that to you when we get there. 26. Angle B is 21 degrees. Side B is 17. Side C is 32. So which one am I dealing with here? Side angle. So, is this acute or obtuse? acute. So I want to go up. I'm going to look at B compared to C. So is B greater than or equal to C?
I don't know. I haven't written it down. It's less than.
It's less than, so since it's not that, I need to find what?
Right?
H. Okay, so H is going to be equal to C sine of B. So 32 sine of 21.
$11.5.
11, is that what you said? 0.5. Good, you remember to go to one decimal place fast. All right, so now I need to look at B compared to H. So B 17, H is 11.5. So is H greater than B?
No.
Is H equal to B?
No.
Is H less than B less than C?
Yes.
Yes, so what does that mean?
Two triangles.
Two triangles. So H less than B less than C, so I'm going to have two triangles. So I'm going to give you a visual here of what this looks like. So I'm going to draw one giant triangle, first of all, and then within that I'm going to have two, like a smaller triangle. So I'm going to have one really big one and then one small one. So this is C, it's 32. This is angle B, which is 21. Side B is this side over here. So this is 17, but it's also here of 17. And then this is going to end up being angle C over here. But this right here is also going to be angle C. And then this is going to be angle A, side A, which is going to be changing. So I'm going to do this for triangle 1, and then I'll do triangle 2 and then blue. So the big triangle, we have C is 32, B is 17, angle B is 21, and then I've got to find the other pieces. Nope, I put that in the wrong spot. C. Okay, that's the big triangle. Then I have a little triangle like that, where this is angle A, angle C, angle B, which was given as 21. C is 32, B is 17, so then side A is what I'm trying to find over here. Okay, so those are my two triangles. People often think that like one of them is this one and the other one is this one, but that's not the case. Okay, it's the big one and then it's this little one. So I'm going to solve for the big one first. It's the easiest one to find. So let me see. Let me put in the known stuff up here. 30, 17, 32, 21. So I'm going to solve for angle C first. So sine of C over 32 equals sine of 21 over 17. So since this is going to be long, I'm just going to go ahead and do this. The inverse sine of 32 sine of 21 over 17. Did you type it in right?
No, I pressed 3 and I got faded out.
Huh?
I don't think so. I mean, I have 42 now.
Okay. So angle A is what I don't know yet. So I'm going to do 180 minus 21 minus 42. I don't think that sounds right. Or wait, maybe it is. Maybe it is. Okay. I was looking at something else. Alright, 117 degrees. So now I can find side A. So A over the sine of 117 is equal to 17 over the sine of 21. So A equals 17 sine of 117 over the sine of 21.
Which triangle is in this triangle?
Huh?
Which triangle is in this triangle?
The big one.
Okay.
$42. Okay. Alright, so this is triangle 1. So triangle 1 is this big triangle right here. Okay. So now, to get triangle 2, this one's done a little differently, because if you just started to work it again, you're going to get the exact same information. Okay. So what we have to do is this angle here went from being an acute angle, okay, to over here. Now it looks a little more wide open. It is now going to be obtuse. Okay. So what we do is we're going to do 180 minus, okay, this angle value that we had for C over here. So whatever this corner angle is what we subtract from 180. So it's going to be 180 minus 42 for triangle 2. So let me do it this way. Now, any given information stays the same. So given information, we had angle B, side B, and side C, so that all stays the same. So now to find angle C, 180 minus what it was in triangle 1, which was 42. So what is that one? $138. So now, this one, triangle 2 is a lot easier to solve because that was how we found angle C. Okay, then to do angle A, it's 180 minus 21 minus 138. So that's 21 degrees. So now side A over the sine of 21 is equal to 17 over the sine of 21, which sine of 21s are going to end up canceling. Which that doesn't always happen, but in this case it did. So side A is 17. So second triangle was a lot easier to solve for. Okay. Now also notice that angle A in triangle 1 was obtuse, but in triangle 2 it was acute. Okay, so those are also going to switch, but you have to use the angle in the bottom right corner, the way that we set them up, for finding the second triangle. Okay, so whatever side length you're given to start with, okay, that doesn't have an angle, that's the angle that you're going to be changing for the two triangles. Okay, so triangle 1 solutions up here. Triangle 2 down here. Any questions about that one? Those are, they're the hardest ones, but just because there's more work involved. Obviously, they're not too bad. All right, area. So these are formulas I forgot to give you yesterday when we did, or whenever we did our notes. I don't know. Was that yesterday? So I'm going to give you those formulas really fast. So area, and it's for when you're given a side-side angle situation. Okay, that's what these are for. And so, or not side-side angle. When you're given two sides and an angle. So it'll be, anyways, you'll see in a second. 1/2 AB sine C. 1/2 BC sine A, or 1/2 AC sine B. So it's half of the two side lengths you're given, and then the angle, the sine of the angle that you're given. So in general, we know that the formula for area of a triangle is what? 1/2 base times height. So they've essentially gone through and found another way to solve it, or another way to find area when you don't have that information, or it's like a weird triangle or something like that. So 34. C is 96 degrees, side A is 7, and side B is 15. So super simple, we just plug in. So the area is 1/2 times A times B, so 7 times 15, times the sine of 96. And again, these would still be in degree mode. And then 36. Angle B is 60 degrees. Side A is 19. Side C is 14. So same thing. Area equals 1/2 times 19 times 14 times the sine of 60. 115.
So there.
Cool. Any questions? This is a lot. All right, then your problems are 3, 7, 19, 21, 27. And 27 is a finding the error in what the person did, just so you know. And then 31 and 35. So I'm trying not to give you a ton of solving the triangle because obviously they're time consuming, but if you feel like you need to do more after you do those, I would highly recommend it because, you know, obviously need extra practice. I will give you some time tomorrow in class because we only have like 10 minutes left today to work on this, and then we'll probably do the notes for 13.6. So that way we'll be ready for that because there's no notes video for that either.